Waar die wilgers welig spruit, doringboom sy skadu sprei, soos ons groei in kundigheid, mag U ons lei. Sien ons hoe hier lei met die hand, laat U sien rus oor ons land. Three strong streams united flow, Africa stands proud and tall. As we learn, we trust, we know God is in control. Bless us, O Lord, guide us with grace. May Northwest be blessed always. Bless us, O Lord, sien ons hier. Ore Jehovah se morena, sien ons, bless us, O Lord.
Dear ladies and gentlemen, welcome at this inaugural address of Prof. Jan Meyer. It's indeed a privilege for me to specifically welcome the following. Prof. Sonja Swanepoel, Acting Deputy Vice-Chancellor, Community Engagement and Campus Operations of the Meyer King Campus. Prof. Ntebu-Moroke, Acting Executive Dean. Prof. Herman van der Merwe, Deputy Dean Teaching and Learning of the Faculty of Economic and Management Sciences. Of the same faculty, Prof. Bab Surijal, Deputy Dean Research and Innovation, and Prof. Dan Metzeleng, Acting Deputy Dean Community Engagement. And then to the Northwest University Business School, friends and colleagues. Specifically also welcome to Prof. Jan's friends and family, especially his wife Melanie, for the years of support and understanding, all the children for their understanding, his close friends who know who they are, colleagues, both past and present, and other friends, and as Prof. Jan says, allies and enemies. The inaugural address is an opportunity for newly promoted professors, albeit in this case since 1 January 2019, to inform colleagues in the university and the general public about a research career, and update colleagues on current and future directions in research. It's also to grant the new professor, and in this case the bit older one, the opportunity to answer for himself regarding his position in and contributions to the subject field, and with regard to how you understand your mission at the NWU in the context of your subject. It also represents an essential component of the university's public events program, helping to create a wider awareness of the latest development and research in the faculty and the university. The Faculty of Economic and Management Sciences are in a privileged position to have 7 members of staff presenting inaugural addresses this year in a variety of disciplines. Prof. Jan, tonight you can celebrate an important personal milestone with family, friends, and both previous and current colleagues. This is an opportunity for the university to recognize and showcase your academic achievements. Tonight you will share with your colleagues, both within the faculty and more broadly, your research interests. Having the privilege to introduce Prof. Jan Meyer, I will read his abbreviated curriculum vitae. Prof. Jan Meyer was born in Pinetown, Natal, 10th April 1956. He matriculated from Pinetown High School in 1973 and joined the South African Air Force as a pupil navigator in 1974. He then moved to the Electronic Data Processing Division of the SANDF as a programmer and later systems analyst. Hereafter, Prof. Jan became a project manager and implementer of logistics projects and ultimately remaining in the Air Force for 21 years, leaving in 1995 as a colonel and the logistics manager of Air Force Base Swartkop. During this time, Prof. Jan Meyer had obtained his BA from UNISA in 1990, his certificate in logistics management from UP in 1991, and MBL from the SBL in UNISA 1995. So those of you who know Prof. Jan will know the numerous types of abbreviations that he uses, not excluded from his CV this evening. He joined Excel IT as a project manager on logistics projects for the SANDF until 2002, when he left for the academia and joined Monash University in Rymsig. Here he started his academic career as a senior lecturer in, amongst other, IT project management, completing his PhD from UP in 2002. And during this time, he also completed a graduate certificate in higher education from Monash, Australia in 2006. Prof. Jan remained with Monash until 2009. In 2010, he joined Mill Park Business School, and on 1 January 2013, the then Graduate School of Business and Leadership at the NWU campus as faculty and associate professor. In 2015, he was appointed as the acting director to this school until its integration into the merged NWU Business School. That is in 2018. Prof. Jan then assumed the position of Deputy Director of the school to this date. Prof. Meyer was promoted to full professor with effect 1 January 2019. And yes, I reiterate, it's now the end of 2021. His research interests include project management, supply chain management, and data security. Other fields of interest center on ICT 4D, information knowledge management, e-governance, and e-government, as well as issues in the public sector. Prof. Meyer has published 21 papers in accredited journals, 9 in the popular press, and 2 book chapters. Prof. Meyer is also on the editorial committee of accredited journals and conferences and serves the CHE as an evaluator. He is also an academic board member to 2 higher education institutions and a board member to the African Institute of Supply Chain Research. He is also a consultant in the fields of logistics and project management. Prof. Jan, may this inaugural address be a very special one to you. It's been a privilege and honor to know you and work with you. May the dear Lord bless you and enable you to remain an active servant of the academia. Thank you so much.
Good afternoon, ladies and gentlemen. Welcome to this session, where I would like to present to you 40 years of work in 40 minutes. Quite an anomaly. But let us try that. I want to share with you my passion, one of my passions, and this is logistics. The other being project management, but I'll start the list now, it's going to continue forever. So let me just focus on today's topic. Integrated logistics support management for systems lifecycle support. And you'll pick up as we go along what this is all about. When we consider logistics, it's an old concept that relies on the premise of the 7 R's. The right item in the right place, right quantity, right condition, right user, right time, and most appropriately of all, right cost. Now, it actually originated from a story, which was an inventory item that caused the war to be lost, where a soldier said that the battle was lost because of the want of a nail, and the war because of the want for that battle. Okay. But in logistics management, the origin of logistics is found in defense. The SCM, or the supply chain management, in turn originated from this concept, the integrated logistics support concept. It utilized the basic premises of logistics and put it into business perspectives, which was cost-driven, and then looked at it from an operational perspective in order to get to the cost factors of it. The integrated logistics support management, in turn, is both operational and engineering. Now, this becomes important in the long run because in the supply chain, the engineering component was lost, and only focus was on the operational component. So the whole point of supply chain became lost in the process of the integration to something that didn't exist in the supply chain. So operational and engineering logistics extend to the support equipment that it supports. But in supply chain, that does not happen. So that's another negative for the supply chain management. When we look at the ILSM integration application, this, in the product environment, leads to lifecycle support. And lifecycle support is ultimately which supports every product that you have. Every cell phone, every laptop, everything that you might possess has a lifecycle attached to it. The length of that lifecycle depends on how it was developed. This brings us to the problem statement then that we're going to address. In today's environment of the fourth industrial revolution, with ICT developments as they are, augmented reality, the need for process improvement becomes much greater. Also, the whole world has got this drive towards leaning of processes. Now, when one starts leaning processes, the whole idea is to optimize the product in its life cycle from a cost perspective. Everything has to do with the cost. But you can't do that without losing something or gaining something else. Normally, if you do something at a lesser cost, you lose quality, which means you're going to lose reliability. In this case, we're advocating the increase of such so that even at a decreased cost, you have a better availability at the end. So the life cycle cost effectiveness depends on the appropriate reliability, availability, and maintainability. But the system or the supply chain management life cycle effectiveness had experienced a problem in this because its effectiveness and sustainability is on the decline. And that's what we want to stop. We don't want to do away with the supply chain management. It's embedded in our whole process of operations, of manufacturing, of service, of supply. It doesn't matter which one we look at. But we have to optimize that which is already there. And therefore, the solution may be found in the integration or the integrated logistics support management system for life cycle support. When we consider the issue of the supply chain management and we look at the evolution of supply chain management, it is found in exactly the fact that pre-1960, we had a fragmented amalgamation of units. There was inventory management, there was requirements management, purchasing, all were loose-standing activities. These were grouped together at some time post-1960 to 2000 into what they were called purchase management or inventory management or even distribution management. And then ultimately towards the late 90s, 2000, they became integrated logistics support. But then some people decided that integrated logistics support needs to be developed further, and they brought in strategic planning. Now, nothing wrong with having strategic planning as part of your ILS, but the minute that happened, they started losing focus on the minor components. That fragmented components that were beautifully contained in specific managerial groupings which were managed was lost, especially the engineering component. A lot of the operations, that's the inventory management, that's the procurement, that's the purchasing, that was retained, but the engineering was lost. And the quality control and quality management, the continuous quality management, it went ahead, but there was something missing in the CQM. So continuous improvement became problematic. And that's why we have the decline in the supply chain today. If we map defense and business, remember that logistics are originated from defense, we can essentially find that ILS is very pronounced in defense, whereas in business, it tends to be more supply chain management focused. Now, bearing in mind that the supply chain management operates at a higher level than what the ILSM will operate. But it is not necessarily that level that makes the difference. It is the application of that level or the content of that level. Defense applies the ILS within the supply chain management mode. And that's the difference, because business declares compliance to the SCM and some of the operational components in its inbound operations, outbound logistics only. So it doesn't integrate the whole of the logistics spectrum. This is problematic. The business states sustainability, but defense applies sustainability, and this is where the major difference comes in. With the sustainability through supportability. And the minute you bring supportability into it, and this is the difference from defense to business, that means you start looking at the technical aspects, the engineering components of logistics. So you're starting to look at reliability, availability, maintainability, the RAM efficiency and effectiveness. And the minute you start looking at RAM efficiency and effectiveness, you start looking at the cost benefits that this can bring about. Business looks at cost and considers RAM as something that they need to manage on the side. Defense applies the systems and product engineering, whereas business accept the product engineered in an as-is phase. And this is typical of us today. You purchase your laptop. There it is in front of you. You do not care about anything, let me just get that. You do not actually care much as to what the technical compliance of this laptop is. In all purposes, this laptop must fulfill its fit, form, and function that it was designed for in your eyes. But in an ILS mode, we want to know and say, okay, it comprises of this, which has a lifespan of this, and has got a service interval of X, Y, and Z. But in the supply chain management mode, these considerations don't carry any weight. And this is problematic when it comes to a cost perspective. Okay, looking at ILS management per se, we will then, in terms of this, need to consider the hierarchy of systems within the systems development. And why do we need a hierarchy? When we consider the ILS mode, in the hierarchy, the entry and exit points of the product and system is at different levels. So for the purpose of the ILSM, we've identified 8 levels in the hierarchical system, which we'll get to now. And all operational engineering logistics management parameters depend on that particular exit or entry level. And all are also dictated in the Plan, Do, Check, Act cycle, which is important, especially when we start capturing the management information system. Because one of the biggest problems we have today is that we'll discard an item too easily because it did not perform as we had wanted it to perform. Procedural direction in terms of this is given through some documentation, and this we don't even read. So we don't even look at that. The specification of your machine, product that you have. And if I ask anyone in the audience today, what is the technical specification of your laptop, what would your answer be? It's got 8 gig RAM, it's got a hard drive of 1 terabyte, and that's about where it ends. It doesn't say I can do this with it. The limitations is this. It's got a motherboard with this ground speed. You don't know any of that. Now, that's part of the technical documentation that is actually supplied, but not used. So, the continuous improvement that we need actually to supply to the product supplier, because ultimately you've purchased this 8P, the HP people do rely on you for some feedback as part of the life cycle, not only of the product that you have, in the maintenance of the product that you have, but we've got so used to discarding the product after X amount of time that we don't worry about the upgrades on it anymore. And there we have the system hierarchy. 8 levels, the first 3 levels being the most basic of levels: raw material, component, and subcomponent. In the supply chain, that is essentially the 3 levels which the supply chain inbound logistics focus on. But then they stop, because to them operations exist where there's a transformation or a value add, then an outbound logistics component, which then change the product into something of the level 4 or 5, which in our definition of the system hierarchy is the product support level. But in order to do that transformation and the management of the product at a level 4, 5, we have to understand the technical requirements of the product. Now, ILSM in an organization that manufactures, for instance, a computer, is at various levels. The organization as a whole functions as an ILSM, as an integrated logistics support management component. But the operations and its in and outbound logistics also have its own ILSM, because you have raw material, levels 1, 2, 3, coming into operations. Operations transform this material into something that they place into store for sales, which is now something different because it had value adding. So it's not only a supply chain, it's now a value chain in this process. And having a value chain change the total product composition into something else with different requirements means the documentation needs to be adopted and adapted. Now, in our system support requirements, the criteria is set for input for the design and maintenance of the product in the support equipment as well as the main product that we have. And continuous evaluation of this design is required. So although we have these on the market today, it still is continuously revised, and to the point that once you've purchased it today, tomorrow there's a new model out already, because the design had been adapted based on whatever feedback the organization had received. So, determination on maintenance becomes very important through this continuous evaluation. And this continuous evaluation, monitoring and control of the support infrastructure with focus on the continuous improvement is done through the MIS of the organization. Now, when we go back to the SEM, they've got ICT, they've got MIS, but it's for the total organization. There's nothing specific for the inbound or for the operations or for the outbound logistics. You're part of the broader spectrum. And that is okay if you're only concerned about profitability in the organization, total organization. But the main purpose of logistics is to break it down to see what is your profitability margins on the logistics component. Thus, we have to start designing for supportability, reliability and maintainability in the life cycle. And the ILSM, the Integrated Logistics Support Management, needs to support this life cycle through availability. And that brings us to the 12 log elements. Now, in all, these 12 log elements, actual fact, represent probably 10 years' work in 12 seconds. But they come from the engineering and the operational perspective. When we look at the ILSM, that is what should be present in the supply chain to make it a functional whole. The system support elements comprising of operational logistics and engineering logistics, the technical specification. We have trained log staff. We have log information, the MIS. We have material support. We have packaging. We have the technical data. Now, that technical data is a very important component because it derives its data from the LSAP, from the engineering side, the log support analysis plans. And then you have maintenance and support. Maintenance and support also deriving its direction from the LSA, the RAM, the reliability, availability, maintainability, and the change in configuration management from the engineering side. So 12 elements, extremely important, but missing in the supply chain. The ops log integration, operational logistics integration, now it's just the one component we're talking about now. Can't function in isolation. Now just think back for a minute. In supply chain, they take out inventory management, and they take out purchasing, and they place that as a common item. In effect, you can't disseminate it that way. They are an integrated whole, totally and wholly interdependent. There's no specific entry point for these 6 elements. But one might say that technical publication is the main origin for every other influence because it's influenced by the LSAP from the engineering side. That's where you get your FMICA, your FROCAS, which is your failure reporting analysis and corrective action systems. And they dictate your mean time between failures, your mean time between repairs, your mean time between servicings. And this influences the maintenance. When the maintenance being influenced will then start being an effective driver of your stores, your materials management, the requirements management that goes with that. And again, once that happens, the skilled staffing that's required to do both maintenance and materials. But then there's also the third aspect. You need facilities to do the maintenance and to have this materials contained in. Because materials and the storage of materials isn't just packing things away. There's a whole science in that as well. So, at the end of the day, all 6 work together. To depict it as a sketch, we can look at it from this perspective. There's a total interaction with each one affecting the other. Now, this integration of the 6 elements also mean that there's a feedback loop, because once something is not met in terms of the parameters set by engineering logistics, engineering needs to be informed. But let's first look at the engineering logistics integration. In the case of engineering logistics, we again find that the 6 elements, design expertise, system expertise, probably is the origin for the whole process to be initiated once the user has set its demand, its need, its scope definition if we talk project terms. And this design will then be developed according to whatever R&D is required for this. And this continuous interaction of this design will result in reliability, availability, maintainability parameters being set, contained within a log support analysis, which is eventually transcribed into a log support analysis plan. Now, this log support analysis plan, the baseline plan for your technical documentation on the operational logistics, the link there. Then you have this handover and the configuration management, this maintenance of operations, the materials management, and so on, as is needed. Now, when that happens, any product that you have, this laptop, your phones, is under a specific configuration. It's got a model number, and that model number represents a certain amount of X, Y, and Z spares. Those spares, in turn, is linked to a specific life expectancy, the life cycle. Some of the stuff is repairable. Some of the stuff is replaceable. Some of the stuff is just expendable. So once they break, they're finished. And that is what this LSAP will dictate to the technical documentation. The engineering depicted again, pictorially, is the 6 elements working together. And as you develop from design to system expertise, setting up the first baseline, and that's where your version control starts coming in, your RAM parameters being set, your logistic support analysis being composed with a plan being derived from that. The integration of ops and log, engineering logistics, is captured through the technical publications, the LSA, the LSAP requirements. But what is important now, as I'd mentioned before, according to the FRACAS and the FMICA, the failure analysis system that you have, the mean time between repairs, mean time between failures, and mean time between services needs to be managed in order to see whether you are conforming to the performance of the product. Now, bear in mind that if you're in the business of producing the product, you have the ILS management integration in the operations of your company as well as the company as a whole. So you have an integrative process for the ILSM. And you need a very strong LMS or ICT system to manage this information coming through. Corrective and remedial activities needs to improve the product so that it can again be placed back into operations. But this is done in the engineering component, which takes it back into the operations for use again. And this loop will continue for the full life cycle of the product. Pictorially, everything works together. You've got your engineering on the one side, giving input into the operational aspect, operations using the item, feeding back information, conformance to performance, and if there's adjustments being required, engineering will adjust. A new configuration will be brought out, a new part number will be generated, and this will go through to operations for use in the system, in its application. Now, when we look at this ILS, and we compare this to the supply chain, and I've tried to bring that into the picture the whole time. We have the supply chain currently considering inbound logistics, so the raw material, that's levels 1 to 3, bringing it into a component manufacturing system, and then placing it into the end product environment. But once we've done this, we do not look at what the engineering requirements are. We look at the physical or operational use of the item, placing this into depots, selling this off into the end user game. There is a feedback loop, but this feedback loop usually concerns about it broke, it needs replacement. There's no real technical specification as to the conformance to the specification on this item. And that is what is missing in the supply chain process, where ILSM will capture this information. The current supply chain does not do it. Think for yourself. At this stage, outbound logistics is concerned with a product being warehoused, being shipped, and being sold off. That's it. And then they're concerned that that product mustn't come back within its warranty period, because a warranty claim means it's a lot of money. Whereas ILSM says we have quality built into the product, it's got a specific life cycle, it will last that period. And we know exactly what this product contains. Now, again, revisiting the supply chain evolution. We had everything that we had required in the 12 logistic elements. Fragmented, yes. Then we had it combined in the 1960s to 2000, and then it got lost when we brought the whole pestle, the external environment, into play, which is a pity, because in effect the supply chain, and this is also why the decline is there in the supply chain life cycle effectiveness. If we take, and we use Porter's model for the supply chain, for instance, inbound logistics, outbound logistics, operations in between sales and marketing, we can actually take our ILSM and put it into the inbound logistics and function that whole inbound logistics from the ILSM, which will make it much more effective in the application of the products that you purchase, the products that you push through to operations, and the product that is now a new component, a level 4, 5, 6, in the outbound logistics for sales and marketing. However, within the organization itself, ILSM resides on top of everything because the organization itself also has a logistics function. It's not only contained in the inbound logistics and operations and outbound logistics, and companies forget this particular element completely. And that's why that cost component rockets out of control. So, inbound logistics, raw material, but not materials management in the supply chain management context. Operation management uses the inbound logistics output, that which they submit as output, and renders a product as output to outbound logistics, where the elements of operational logistics and the outbound logistics, again, is only warehousing, distribution, storage, and shipping. Again, this is wrong, because here you've got to take the full ILSM and put that into the outbound logistics to make it effective, and then start managing the life cycle. If we use this, and we use the ILSM, then we will start including the engineering logistics, which is currently precluded from the supply chain management component. And we need to address that absenteeism of that product, of the engineering logistics, through the ILSM. That's going to do a lot more in terms of uplifting the supply chain management life cycle effectiveness as it is standing right now. So, returning the engineering logistics, we've got to design the development and the baseline for this specific performance parameters, and not just accept the output. Where does this effectiveness come in? And this is quite clear. If we look at logistics system effectiveness, two very important components are there. It's the product effectiveness and the cost effectiveness. This I mentioned at the beginning. Cost effectiveness is what can cost the company quite a lot. But product effectiveness relies on availability and dependability. Now, when you buy something, you want to know that this specific product is going to last XYZ months, years, whatever the time period might be. But having said that, the availability and dependability has certain attributes, reliability and maintainability. And these need to be built in to the various levels. Now, again, considering the supply chain, and we are now looking at the outbound logistics, we need to bring into play this effectiveness in the outbound logistics in order to halt the decline in the effectiveness of the supply chain. We consider the supply chain life cycle, which we've now basically flowed into. Logistics is always from a systems perspective. It's a holistic view. You can't look at it from just the one component, which just inventory or just procurement or just requirements. You can't do that. You have to see the full picture, because every component affects the other component. And consider the initiation of every phase as underlying and needing monitoring and controlling. So we have the normal life cycle or the system process groups: initiate, plan, execute, monitor, control, which is the underlying basis, and close out in the life cycle, and playing into this hand the life cycle itself, which is through its conceptual design, preliminary system design, and the rest up to the point of retirement, because that's another failure that supply chain had. The retirement or disposal component, although they captured it in the reverse logistics aspect, was not addressed to the fullest. There is much to be learned from retirement and disposal, reduce to produce. You could even upgrade, you could do a lot of things with that component as well, with the disposal component. But looking at the life cycle, we have then to start looking at the breakdown of the life cycle, applying the process groups. But if we just look at the conceptual design, and each of the components of the life cycle, and there's 6 of them, need to be broken down in terms of the design for production capability, design for support capability, and the design for disposal capability. So again, it becomes an integrative whole for the life cycle. Now, the minute that we integrate and become integrative in our approach of the ILSM, we start achieving cost benefits. Again, holistic approach, and we look at the ops and the log elements, and the overall ILSM model, monitoring and controlling becoming very important in this process, with the feedback loop being the most important component. The engineering parameters, our FRACAs, our FMICAs, MTBFs, MTBFs, MTBS, all needs to be adjusted. For instance, we have to start working towards the point that our mean time to repair needs to be less time consuming. The mean time between failures need to increase. So in other words, you have to spend less time in bringing spares into due to failures. And you have to have longer periods between servicings. Now, there was an anomaly in this in the motorcar industry when they started initially to lengthen service periods of cars from 10,000 kilometers to 15,000 kilometers to 20,000 kilometers. Now, this is the example one can use. Now they've brought it back from 20,000 to 15,000 kilometers. Why was that? Because there was some preventative maintenance that they had to consider or reconsider. So this is a balancing act if one considers it from that perspective. So less corrective action is required. That would lead to a reduction in cost, which is our focus. So our reliability will increase and our availability will increase. And on all, very importantly, we have to start considering our supplier relationship management and our customer relationship management, the two ends which we in all instances or in a lot of instances forget. Supply chain, huge focus on the customer relationship management. That's the servicing to the sales and marketing department and so on. But the supply chain, the supply relationship management, not enjoying the same attention, which is problematic because a lot of quality lies in the supplier. And the process then is to focus on an availability cost relationship at the end of the day, where we can have a certain cost line. We say, okay, this is the affordability line that we have. This affordability line against our total cost curve will give us a certain area of play. This area, we can now say, we can put our required availability against a specific percentage point, which means we make a profit, and that is where we're going to stay at. Alternatively, we can invest what we make to improve the availability even further. So our minimum acceptable availability cost, on the one hand, against a affordability line, against our total cost curve, gives us an idea as to how we can maximize this trade-off area to the benefit of cost. Now, this also teaches us a lesson in the sense that why do we need 100% if 90% will suffice? And that is something that this trade-off curve, in terms of the cost, will allow us. Another aspect that we have to manage is the maintenance cost, or the maintenance versus the cost component. Now, maintenance, we have two major components there. We have the unplanned and we have the planned maintenance. Now, the planned maintenance, relatively predictive, but there's also the corrective. And those can be managed in terms of an increase in the mean time between repairs, the mean time to repair, mean time between failures, and mean time between servicings. It is the unplanned, the unscheduled maintenance that's the problem, because we have no control over that. And there could be any reason for that. And that needs to be minimized to the maximum, if one can put it that way. But at the end of the day, we have to try and bring that cost component down as much as possible. Now, for the life cycle component, there's got to be a synthesis in the analysis and design of the log and the maintenance support of the infrastructure. That's got to be defined. It's got to exist. The acquisition and the implementation with a follow-on maintenance and eventual retirement and disposal is required. Now you can see that's the life cycle parallel that we have. The process groups initiate each of these components. And when they initiate each of these components, obviously there's monitoring and controlling of this, and there's a feedback loop being created, with ultimately leading to a dependability or a failure rate curve, which gives us an idea when an item needs to be phased out. Now, although the LSAP will give a specific life cycle indication, in other words, it will indicate the potential for this item, let's say 6 months, year, 2 years, 3 years, whereafter you can either do a midlife update to upgrade it and redeploy it again. Alternatively, you have to phase it out and replace it with another item. In this dependability, the measurement needs to be continuous. And over the period of normal application, the parameters need to be managed to the point where the LSAP gives you the indication there should be a variation occurring at that time. When we look at the system, logistics system effectiveness in this process, again, we've got to look at a target. We've got to look at the as is, where we're standing now at our cost, our affordability cost. Remember the previous affordability cost line? From that affordability cost line, we've got to see in our targeted zone whether we can get our effectiveness to that point. And it is possible. The process groups will assist us in implementing this total integrated logistics support management plan of ours as part of the product and system support environment. And we can target a specific design parameter for our availability. The validity of the approach, the systems approach, must be considered against the achievement and the deployment of the continuous improvement scale. Now, if we consider this product support and system support life cycle, this now means that we've got the ILSM, the 12 elements, engineering logistics integrated, the integrated operational logistics, the integrated ILSM, functioning into the process group, each initiated, each planned, each executed, the monitoring, controlling occurring, and so forth. But importantly, that this system and product life cycle is now populated vis-a-vis this whole process groups, which contain the ILSM. Ultimately, each of these elements, this conceptual design, will then have not only the initiated, the planned, the executed, the monitored, the closed out, but also the total ILSM contained within that area. And ultimately, this might lead to a change in the organizational interface, where you then would have system managers, and we still advise that a system management approach be deployed in organizations under the auspices of a proper logistics manager. And this could be somebody under the CIO, but this is something that's absolutely essential in the whole life cycle approach. There's different contracting models that also needs to be thought at the various levels which we function. And it could either be, and this is it's not confined to the organization. It's external to the organization. So you can source in or out. But the principle remains that you have to consider each of the organizational requirements. And those requirements, those business units can then function to satisfy a requirement, or you can contract somebody else in. So you can have a depot, you can have a unit, whatever the case may be, functioning towards this wholeness. And looking at this ILSM support, and I come back to the slide where I say that we've got this effectiveness mode, where we've got cost effectiveness and product effectiveness. Now, this process of ILSM was implemented. And I'm not using the organization, that's not neither here nor there. They had availability of product of 45% in year one. It went down to 40% this next year. This was just for the 2-year snapshot that I took. But the important component was that the budget had increased from 100 million to 128 million in that decline of operations. After ILSM was implemented, the availability increased from 40% to 64%. But what is important, the budget decreased from 128 to 84 million. So it shows that the ILSM does work. So if we consider what the problem statement was, the decline in system effectiveness, and what I've illustrated up to now, it is the process of the absence of the ILSM in the supply chain, Not the supply chain at fault, but the supply chain requiring more logistics effort to increase its system effectiveness in the life cycle of the system. Then the supply chain will also function at a greater effectiveness, efficiency, and at a lesser cost. So, using all these conditions, the CQM and the TQM starts playing an important role in this. We have to look at lean and process improvement because we are no longer in the fourth industrial revolution. We're moving into the fifth. And we have to start considering also our augmented reality, our AI and ICT for modeling purposes in our ILSM. Ladies and gentlemen, I thank you. Vote of thanks from my side. I would like to sincerely thank Prof. Sonja Swanepoel for the period that I not only served with her on the Mafeking campus, also for all the opportunities that she had given me in this process and through time. And I appreciate everything that was done in that period. At this point, I also wish to thank the business school, and in particular the executive director, the chief director, Prof. Jan van Romberg, for his contributions, his input, his understanding, and his support in my endeavors to this particular point in time. As everybody will probably realize, that although this is an inaugural lecture for myself, it's also the pinnacle of my career, so to speak, in the sense that it covers the retirement or the exit of my career at Northwest at the business school from a permanent perspective. So thank you very much to Prof. van Romberg and the business school for this opportunity, and also saw this through various other stages. To all the colleagues, the friends, my wife especially, which suffered tremendously under my abnormal workloads and wish to get things done, I wish to thank her for the perseverance and the support that I had enjoyed with her and everybody else. And in general, just to all the friends and family, I want to say thank you for understanding, thank you for the support. More particularly also in this particular event, I want to thank Esme for the support that she had rendered and that she had supplied. So in all, thank you to everybody. Thank you for taking the time to listen to me. This is much appreciated. Thank you.
Dear ladies and gentlemen, good evening. Dumelang, goeienaand. What a wonderful privilege to participate in Prof. Jan Meyer's inaugural lecture. It is indeed an honor, as I was part of his journey since his appointment on 1 January 2013, and up to this pinnacle of his academic journey, becoming a full professor. Prof. Jan, since his appointment as associate professor, and then later in 2018 as deputy director, always strived for excellence. And this reminds me of a quote of Michael J. Fox, who claimed, "I am careful not to confuse excellence with perfection. Excellence I can reach for, but perfection is God's business." As I reflected on your inaugural lecture, I once again realized that we are not only all touched by integrated logistics, support and management, but it makes the world go around. If it works perfectly, we accept it as a given, like water and electricity. But when things go wrong, we realize how disruptive it can be. Think about the chaos when the Ever Given ship caused a traffic jam in the Suez Canal. More than 400 vessels were left waiting at either end of the canal, when the 400-meter-long Ever Given became wedged across it on the 23rd of March. About 12% of global trade passes through the 193-kilometer canal, which connects the Mediterranean Sea to the Red Sea and provides the shortest link between Asia and Europe. You started by reminding us that logistics is an old concept based on the premises of the 7 R's. Right item, in the right place, in the right quantity, in the right condition, to the right user, at the right time, and at the right cost. Your lecture tonight and years of research culminates in putting forward the importance of the implementation of appropriate ILSM, integrated logistics support management activities across the supply chain management, and how this will enhance the effectiveness of every organization in terms of the logistics support and lead to improved availability at reduced cost. A wise professor indicated to me that an excellent inaugural lecture is to prepare a lecture that will find the balance of the audience. This balance should look like this. 33% of the audience are discipline-specific attendees, and they will completely comprehend, especially the reference to ILSM, SCM, TQM, CQM, AI, LC, RAM, ICT, etc., to mention but a few of those acronyms. 33% will have an average or more or less understanding, but 33% will have a faint or hardly any collection at all. I think you reached this balance. Tonight you made the NWU, the faculty and the business school proud. Thank you for your dedication, hard work, commitment and pursuit for excellence. To you, Prof. Jan, well done, and hearty congratulations to you. Northwest University also want to thank your wife, Melanie, your children, family, friends, and colleagues who supported you on your academic journey. Well done, well deserved. It is my pleasure to hand over to you the certificate of your full professorship, as well as a handmade pen set to remind you of this accomplishment. Well done.